Hi, and welcome to this lesson on section 7.4 from our Algebra textbooks. In section 7.3, we took a look at how to solve systems of linear equations, like we see here, with elimination, which basically means you're going to combine the equations together and try to get one of the variables to cancel out. In this section, what we're going to do is that same approach plus one additional step. The additional step is that here, we're going to have to multiply one of the equations by a coefficient in order to get the variables to cancel out. So let's take a look at how that works. 5x plus 2y equals 16, and 3x minus 4y equals 20. Those are the two equations that we have. So we want to cancel out either our x's or our y's. Two hints as to what to look for in terms of canceling something out a little bit more easily. If you notice that one of them has a positive coefficient for a variable and the other equation has a negative coefficient for that same variable, that's oftentimes an indication that you'll be able to get those to cancel out easily. And that's exactly what we see in this case. So if we look at this first equation, we're going to have to multiply by a certain coefficient here in order to get the variables to cancel out. So we have a negative 4 in the bottom equation. What would we multiply positive 2 by in order to have it cancel out with a negative 4? In order to have it cancel out, we need it to be positive 4y up here. So we would multiply by 2. Good. If you said 2, that's the right answer. So we have 2 times 5x plus 2y equals 16. Now, if we go through and distribute that 2 to each term inside of our parentheses, let's see what we get for our new equation. So 2 times 5x would give us 10x. 2 times 2y will give us 4y. And 2 times 16 will give us 32. Our second equation we can leave exactly the way it is. 3x minus 4y equals 20. And now we're ready to combine our equations the same way we did in section 7.3. 10 plus 3 gives us 13, so we would have a 13x here. A positive 4y and a minus 4y cancel out. And 32 plus 20 gives us 52. To solve for x, we would divide both sides by 13. This is a rather complex calculation, so on this one, if you have to write out the long division or try multiplying 13 by different multiples, that's okay. In this case, 52 divided by 13 will give us 4. And that's the answer for x. Are we finished with the problem? If you said no, you're correct. Good. So we still have to take x and plug it back in order to find a value for y. So let's try plugging it back into this first equation here. We would have 5x. So instead of x, we're going to put 5 times 4 plus 2y equals 16. So this is just that first equation, except we're replacing x with 4. And if we continue to solve this one, 5 times 4 gives us 20. And then, in order to get y by itself, we subtract 20 from the other side, or from both sides, really. And then we get 2y equals negative 4. If we divide by 2, y will equal negative 2. Now we have a complete answer for our system of linear equations. We have a value for x and a value for y. That tells us the solution to that system of equations, or in other words, it tells us the coordinate where those two equations would intersect on a graph. If you have additional questions, please feel free to leave comments, and I'll post videos addressing any of the individual problems or concepts that you'd like to see touched on a little bit more. Thanks for watching.